Okay, after the reaction rate testing, we are moving into another section, the equilibrium testing. We are trying to check the Le Chatelet principle. So now part E, chromate, dichromate equilibrium. This equilibrium will involve some color change, so you can see if the equilibrium shift to which direction will give you what kind of a color. So first, let's observe the color of this reagent. So this is 3 milliliter of the 1 molar potassium chromate solution. Check the color, write down the color in your report. Okay. Now I'm going to add several drops of the sulfuric acid into it. Okay. Then you're going to check the color of the solution. Yeah, you can see that in the equilibrium we need acid. Wow. Several drops, you can see the color. Okay. Right. Now, I'm going to add 6 molar sodium hydroxide NaOH to this reaction, and you're going to check the shift of the equilibrium. Okay. Check the color, sodium hydroxide. You see the big change of the color. Which direction this equilibrium is shaped by the sodium hydroxide? Think about that based on the color change of the reaction. Okay. So that's our part E. Let's move to part F. Part F will check the iron 3 chloride and iron 3 thiocyanate equilibrium. So first we needed to have the equilibrium set up. So we need to add the thiocyanate, SCN, the ion, okay, and the iron 3 chloride, okay, into the solution. We develop the equilibrium. So you can first, take a look at the color of them. So let's check the color. Maybe I'll put this in the test tube first so for you to see the color of it. Okay, so this is the iron 3 chloride. Check the color. Okay, so I'm going to dump that in here. So let's see the other one's color. Potassium thiocyanate. That color or colorless. Okay, in there. Now you can see this equilibrium is developed. That would be the color of the equilibrium right now with the amount of those added. Okay, so I'm going to dump this, pour this into the 3 test tubes, separate them. Okay, first one, some, second one. The third one is going to be our control. So this one will be like this. Then the other 2, I will add something to shift the equilibrium. Then we can check the change of it by controlling to this controller. So this will be our control number 3. Okay. So in our number 2 test tube, we need to add 20 drops of the potassium thiocyanate. Okay. So number 1, add several drops, 20 drops. Okay. Now, 20 drops. This is a control. See the difference? So which direction is shifted to? Okay. Yeah, this control, this would be the color of the product, iron thiocyanate. Okay, now this color means what? More of this color or more of the original, the reagent's color? Think about that, okay, compared to the color you put in your report. Alright, so it's number 1, 2, number 2 tube, test tube, we needed to add 20 drops of the iron chloride. Okay, so I'm going to add this iron chloride. Control. When you redo this part, I think this result is a little fishy here. Let me redo that quickly. I added too much of it. This is the original. This is our control. So I'm going to add a little bit iron chloride. Changed. It's almost the same color. What we expect to see should be darker red color here. Okay, think about why, because there is an explanation on there. It says what we expect to see and why we have that kind of result. Okay, so now the result looks like almost no change here. So, but I can tell you here, it should be a little darker color here. Okay, and trying to explain why the number 2 should be darker. Okay, this part is a saturated sodium chloride solution. It's saturated, it's already a equilibrium system by what? The solid sodium chloride and the liquid sodium chloride all same speed forming and dissolving. So that's why from outside you don't see any change. It's saturated, it's equilibrium. Okay, but I want to break this by adding the hydrochloric acid in it. Okay, you can see the chloride is part of the equilibrium. So hydrochloric acid will introduce some ion into the system. Okay. Check close. See what's happening. Okay, then check the equilibrium shift to which direction and why.